Welcome to Algebra 2.1 review of Systems 3.2. The last lesson we discussed what systems were, so now you have had your experience with graphing them, and you can see sometimes it's hard to tell what the exact point is. So we do have other methods of solving. The first that I'll show you is substitution. If you've ever played sports, you know how you substitute in one player for another. That's basically what you're doing with substitution method in solving a system. These two equations are systems, and I can easily get the x alone by subtracting 5y from each side. So if I do that, I would end up with x equals negative 5y minus 9. Now because x is equal to this, I can replace x with this. They mean the same thing. So I can take the other equation, 4x plus 3y equals negative 2, and I can literally replace the x with what I find that x is equal to in the other equation. Because at that point of intersection, we have a consistent x value and a consistent y value. So that's why you can intermix these. So we have 4 times negative 5y minus 9 plus 3y equals negative 2. First step in solving that would be to distribute. So we get a negative 20y minus 36 plus 3y equals negative 2. Now we should rewrite with the like terms together. Negative 20y plus 3y minus 36 equals negative 2. Negative 20 and a positive 3 would be negative 17y minus 36 equals negative 2. Now we circle our creepy dude, go up to PIMDAs, and solve for him. We add 36 to each side. That wipes out. We get negative 17y equals positive 34. Divide by negative 17. We get y equals a negative 2. Now that you've gotten that value, you take that negative 2 and plug it into either of these equations, and you'll get the y value, the x value. So we go x plus 5. Instead of y, we'll plug in a negative 2 equals negative 9. The only reason I chose that equation over the other one is it looked a little bit easier to work. So x minus 10, because it's 5 times negative 2, equals negative 9. Now I add 10 to each side, and I get x equals 1. Now you may not leave your equation or your answer like this with an x circled and a y circled. Remember, these are systems. We're solving for the point. So the x goes in the front, the y goes behind, and that is my point. That's the answer. That is the point on the graph where they cross. Now looking at another one. This one, notice there's no x or y by itself or alone, so I decide to do elimination instead. The whole key in elimination is to cancel your variable. So if I wanted to cancel x, I would need to make these opposites. The easiest way to do that would be to multiply the 3x equation by a 5 and the 5 equation by a -3. My other option would be to wipe out the y's. In that case, I would need to cancel out by multiplying this 3 by a 3, and that would be an opposite of that one. That method seems a little bit easier to me, so I'm going to choose to eliminate my y's. So I take that equation, 3x plus 3y equals -15. I put it inside of a great big parenthesis and write a 3 on the outside to tell myself I'm multiplying. I'm going to distribute to each number. So I get 9x plus 9y equals -45. Now I take the other equation that had the -9y, I write it right below, so I have 5x minus 9y equals 3. That's not a -3, just a 3. Now I add these. 9x and 5x is 14x. The positive and negative 9's cancel out, and we get a -42. X equals, dividing by 14, we know that -42 divided by 14 is -3. We plug -3 into either equation. I'll choose this one. 3x plus 3y equals -15. 3 times -3 plus 3y equals -15. -9 plus 3y equals -15. We add 9 to each side, and we get 3y equals -6, or y equals -2. So now we write the point of solution as -3, -2. On the back side of the notes, we have a few more problems. I want to show you what an inconsistent or a consistent system might be. A consistent would be if we have the possibility of a consistent dependent, which would be infinite solutions. So let's see if that occurs. The other possibility is having no solution. So here I'd look at this. It would be easiest to probably do elimination. I'd have to multiply the top one by 4 and the bottom one by 3 to cancel my x's. Have to multiply the top one by 7, the bottom one by 6 to cancel my y's. So I'm going to choose to do the 4 on the top, 3 on the bottom. So I'll rewrite this. 4 times 3x would be 12x. Minus 4 times 6y would be 24y. 4 times 9 would be 36. 3 times -4x would be -12x. 3 times 7 would be positive 21y. And 3 times -16 is a -48. The whole reason that I did that is to cancel those x's. Those would cancel as we add these. Adding -24 and a positive 21 would be a -3y. Adding a positive 36 and a -48 would be a -12. Divide by -3 on each side to get the y alone, and we get that y equals 4. Please pause the video, back it up, re-examine this if you need to. Now that 4 can be plugged into one of these two equations, either one. So I'm going to take the top one, 3x minus 6 times 4 equals 9. One thing to be careful of, make sure whatever variable you've solved for is the one that you plug back in for. 3x minus 24 equals 9. We add 24 to each side. And we have 3x equals 33, or x equals 11. So we still have a consistent solution, but it's a consistent independent. It is a single point for 11. So we'll see if one of these shows up as parallel or no solution. Otherwise, I'll have to give you one in class just to show you that. On this one, the easiest way to cancel would be to multiply the bottom one by 3, so we get the negative 6x. So we have 6x plus 15y equals negative 12. Now on the bottom, when we multiply that, we get a negative 6x. 3 times negative 5y would be a negative 15y. And 3 times 9 is, I think I'm tired, is 27. We add these, the x's cancel, the y's cancel. 27 and a negative 12 would be a positive 15. There's nothing over here, so I'm saying 0 is equal to 15. Is that true? It is not, so we know that it's no solution. So there we go. There's a inconsistent. The last one here, we want to cancel out our variables, so I'll multiply the bottom one by 3 so that we cancel the x's. So 3 times negative 4x is negative 12x. 3 times y is positive 3y. 3 times 3 is positive 9. Now the top equation has a positive 12x, so those two will cancel, so I bring it right over. No need to multiply it. Minus 3y equals negative 9. When I add these, the 12x's wipe out, the 3y's wipe out, and the 9's wipe out. So I find 0 equals 0. That is infinite number of solutions. That means they were the same line. And so we end up with, I'm sorry, my mind just went blank. We end up with a consistent dependent solution. In class, you'll be prepared to do page 164 now and prepare for the Unit 1 test. Thank you very much.